In this video, we are going to create a vignette shader using, of course, Panda3D and the GLSL programming language. So the end result will look like this. So the vignette creates these dark corners, and as you can see, it has this ellipse shape in the middle, and each corner is dark. And this will be the first part of the video, and in a second part of the video we are also going to solve one thing, which is when we resize the window, the shader will be recalculated. Okay, so from PyCharm I'm going to switch to Visual Studio Code because, as I told you in the last video, the GLSL plugin for PyCharm is broken, so there is no syntax highlighting, there is no syntax checking or IntelliSense. And so let's go to VS Code. And in order to have syntax highlighting for GLSL programs or GLSL codes, you have to go to the extensions and just install the GLSL plugin. And let me see, I installed this one. So as you can see, this was created by Sleeves-Q, or what is his name, and yeah, as you can see, it was downloaded more than 400,000 times. So this is the extension what I'm going to use, and it also supports HLSL, so high level shading language, so GLSL, open shading language, or OpenGL shading language, and it also supports CG or C for graphics. So I already prepared some code here. I created this vignette.py file, and in this file, as usual, I'm just setting the config variables, of course importing the needed modules, and one of these modules are the shader module from Panda3D.core. And the window size will be 1280 by 720, and I'm also just going to show set the show frame rate meter to 1. So here I'm loading the PRC file data and of course creating the usual stuff. So a class which inherits from the show base, the mygames init method, calling the show bases init method, setting the background to pure black, setting the camera's position to -4 on the y-axis so it moves the camera back, creating a myShader variable and using the shader.load. And this load function takes 3 arguments. The first argument is the type of the shader, which is SL-GLSL, which means shader language GLSL. The second argument is the shader source or the shader file, and I'm just called it vignette-vert.glsl, and it is in the shaders folder. And also fragment shader, so in the shaders folder it's called vignette-frag.glsl. Okay, so here on this line I'm just loading a plane model. Here reparenting the plane to the renderer so it's get added to the scene graph, and I'm also setting on the plane the set shader to my shader, so this shader. And now also let's take a look on the Vertex shader and also on the fragment shader. So in the Vertex shader, I'm just specified that I'm just going to use GLSL version 3.3.0. And here on line 4, I'm just adding the input of type vector4 p3d_vertex. So this will pass, so the Panda passes through this input variable the vertex positions to this Vertex shader. Also in this uniform, so which is of type matrix4, Panda passes the model view projection matrix. I already explained this in the previous video. And in the void main function, I'm just setting the global GL position variable to model view projection matrix times the P3D vertex. So this will multiply each vertex positions by the model view and the projection matrices, the combined model view projection matrix. So this is the vertex shader. This is that just passes through all the 4 vertices of that plane without any modification. So in the fragment shader, I'm also specifying that I'm just going to use GLSL version 330, which is also considered the modern OpenGL, so it is the same as OpenGL version 3.3. And here I'm creating an output color of type vector4 called outColor. And in the main function, I'm using this outColor to actually set the pixels color. Every pixel will be actually 0 on red, 1 green, 1 blue, and 1 alpha. So let me run this file. So Python and vignette.py, and now this creates this I don't know what's called a cyan colored plane. And also I'm just commented out this line, which sets the fragment color. I'm just going to comment it back, or uncomment this line, the out color, and just set the fragment color to this color. And the reason that I'm not using anymore the fragment color, although it works, but the reason what I'm not going to use the GL frag color variable is this one. So global variable GL frag color is deprecated after version GLSL version 1.2 or 120. So that's why I'm just going to comment this out and use this out color of type vector4. So okay, so we are going to mainly work in the fragment shader, and for the first part I'm just going to specify a few constants, and I'm just going to copy from my second monitor and paste it here, and also comment these back. So I'm just going to create an outer radius, which will be a constant, and it will be of type float. Its value will be 0.65. I'm also going to create another constant, which will be the inner radius, and its value will be 0.3. And the third constant of type float will be the intensity, which will be set to 0.6. Alternatively, you can also set everything on one line. So I'm just going to copy and comment out this one. So here I'm doing the same thing on one line. So const float outer radius, comma inner radius, and intensity. So you can do this way or do this way. I prefer it do rather this way, because I think it's much more readable if it is on separate lines. So we specified these 3 floats, constants, and in the main function what I'm going to do is create a new color vector of type, so vector4 called color, and if I set it to vector4 1.0, it will automatically create a vector4 where each value will be set to 1.0. So the red, green, blue, and also the alpha, or the X, Y, Z, and W values will be set to 1.0. The next thing will be to actually, I need, as in the previous video, I need another uniform, which will be the resolution. So I'm just going to copy this, and here I'm going to set a uniform of type vector2, and this will be the resolution of the window, so the 1280 by 720. So we also need to pass, the uniform is used to actually pass values from the I don't know, front-end code from Panda to the shaders, to the vertex or the fragment shader. In this case we are passing to the fragment shader, so we also need to go back to the vignette.py, and here I'm just going to copy one more line, which will be self.plane.set shader input resolution, and this has to be the same name as this, so resolution. So we are passing to this uniform the values 1280 and 720, so it will be saved to this vector2. So let's go back to the main function in the fragment shader. So we specify the color, which will be a vector 4. And here I'm just going to copy one more line after this one. We are going to create a vector 2 type called relative position, and this will be equal to the GL coordinate that xy divided by the resolution, which is already vector 2. So vector 2 divided by a vector 2, and from these results, so it first evaluates the division, and then it just subtracts 0.5. So also from the x and also from the y. And also going to create a length variable which will be of type float. So float len or length will be equal to the length of the relative position, and the length function returns the length of the vector. So I'm also prepared here something. So if you want to learn more about these functions, you can search like this GLSL length function, and here it says that the length function returns the length of a vector defined by the Euclidean norm. So it just returns the length of this relative position vector. And now also create the vignette, which will be also called type float, called vignette, and we are going to use the smooth step function, giving it the outer radius, which is set to 0.65, the inner radius, which is set to 0.3, and the length. And if you want to learn more about the smooth step function, again go back to Google and search for GLSL smooth step function, and you will find this Art of Code video. Just watch this video because this is the best explanation what the smooth step function does from the Art of Code. And go back to the code. And the next thing what we need is actually set the colors. So here on line 20, I'm just going to set the color.rgb, and this is called swizzling. So swizzling a vector like this glfraccolor.xy or color.rgb or color.xyz, we can do this in GLSL. So color.rgb will be equal to the mix function. We are going to take a look on the mix function. The first argument will be the color.rgb, the second argument will be the color.rgb times the widget, and the third argument to this function will be the intensity. And what the mix function does is just mixes two vectors by this intensity. So let me take a look here. The GLSL mix function, here it says mix performs a linear interpolation between x and y using the weight between them. So this is the first vector, this is the second vector, and this intensity is the weight. And lastly, here I'm just going to delete this line because we don't need this line anymore, this commented outline. We are going to set the out color to the color. So copy this, remove this static color and paste it here. And also don't forget to add semicolons. And I think this is enough. So let me take a look. We set here the resolution. So let me check this. So Python vignette.py. And now, as you can see, we have a vignette on each corner. So it just creates this ellipse shape in the middle, and as it goes to the corners, it goes darker and darker, and it is a very nice effect. But now let me show you one problem we have. So what happens if we resize the window? Of course, now the vignette is actually not working as expected. So yes, by this side it is okay, but with this side it is absolutely not okay. So in this part, what we are going to do is actually every time when we resize the window, we are going to recalculate the aspect ratio, and we are going to set the new resolution to the to this input variable, to this what is it called, to this uniform. And also I'm just going to remove this static 1280 by 720 because if you change the window size, let's say, you also have to change it here. So the easiest way to actually get the window size is, I'm just going to copy this. Okay. So the easiest way is actually doing like this. So self.window.get x size, which returns the window's width, and self.window.get y size. And now let me take a look, and as you can see, it works, but we still have that problem. We need to specify what happens when the windows gets resized. And in Panda we have this event. So I'm just going to add the cell.accept the aspect ratio changed event. And when the aspect ratio is changed, so we change the window size, we are going to call the cell.win.resize method. And I'm just going to copy this method and paste it here. And of course, like this. So the win resize, we are passing it here to this aspect ratio changed event. So the win resize will just set again the plane set shader input resolution to the new x size and the new y size, or the new width and the new height of the window. And now let's take a look on it. So now if I resize the window, as you can see, the vignette gets recalculated every time. So at the end, just review the code what we have written. So on line 20 we are creating a MyShader object by loading the two shaders, the Vertex and also the fragment shader. And of course we are setting it to create actually a GLSL shader program. On line 27 we are setting this plane geometry or plane model to use this shader called MyShader. On line 26 we are going to set the uniform input resolution to the window's width and also to the window's height. So self.win.get x size and self.win.get y size. When the aspect ratio is changed, so when we resize the window, we are going to call the self.win resize function or method, and in the self.win resize method we are just going to, every time when the windows gets resized, we are going to reset the shader input or the resolution uniform to the new size, new width and the new height of the window. So in the Vertex shader, technically there is nothing interesting. We just passing from Panda to the Vertex input p3d_vertex the vertices, and also from Panda we are passing the model view projection matrix to this uniform matrix 4, and in the main function we are just setting the GL position, which is a built-in GLSL variable, to the model view projection matrix times the p3d vertex, which just passes through all these vertices through the model, through the view, and then lastly the projection space. And the interesting thing happens in the fragment shader. So here we are setting the uniform of type vector 2, the resolution, which is the Windows resolution, so 1280 by 720. We are creating an output of type vector 4 called outColor, and we are setting three constants of type float: outer radius, inner radius, and intensity. You can play with these values. So let's say if I set the intensity to 0.2 and I run the program, now the effect is much subtle, so it is still dark but not as much as it was. Or let's say we are setting the intensity to 0.9 and now run it. Now the corners are much darker. So you can play with these values. I'm just going to set it back to 6. Of course this code will be uploaded to GitHub and the link will be in the video description. And the interesting part actually happens here in the main function of the fragment shader. So here we are creating a color of type vector 4. On this line we are creating a relative position of type vector2, and we are calculating the GL_frac coordinate.xy dividing by the resolution. So the GL_frac coordinate.xy will be divided by the resolution.xy, so it will divide element wise. So the frac chord x will be divided by the resolution x, the frac chord y will be divided by the resolution y. And from the result also we will subtract 0.5, so it will subtract from x and also from the y result the 0.5. So let me just show you what happens if we don't subtract this 0.5. I'm just going to remove this and run the program. And now, as you can see, this circle or this ellipse is actually moved to the lower left corner. So we are only seeing 1/4 of the ellipse. So that's why we need to actually subtract the 0.5, because this will move the ellipse into the center of the plane. And so let's undo this. Let's subtract the 0.5 here. And now, as you can see, the ellipse is moved into the center of the plane. Here we are creating a length of type float using the length of the relative position, and the length returns the length of this relative position vector. Here we are also creating a vignette of type float using the smooth step, and we are giving it the outer radius, the inner radius, and the length. And as I said earlier, you should also go to Google and search for these GLSL functions if you want to learn more. And on line 20, we are just setting the color.rgb to the mix function of color. To the first argument, we are giving the color.rgb. As a second argument, we are giving the color.rgb times the vignette. And lastly, we are setting the intensity. So this will mix these two vectors with this intensity. And on line 22, which is the last line in this fragment shader, we are just setting the out color to this color. In the next video, what I'm going to do is actually combine the shader written in the previous video, so the gradient shader, with this vignette shader. So we will have a combined gradient and vignette shaders. So until then, thanks for watching and have a nice day.